everybody, and welcome. This is the first of our keynote talks. It's the open source analytic version, or analytic universe version 2022. My name is Robert Hodges, and I'm the CEO of Altinity. We are the folks that are putting on this conference, and it's a real pleasure to have you all here. I hope we can share knowledge and learn more about open source as well as analytics. This talk is kind of my point of view about what is going on in analytics. I think for everybody present on this in this conference, we all have in some sense a mole's eye view, or put another way, we see one or two spots on the leopard. So what you're going to hear is my perspective from what we see, both from the software we work on as well as the customers and the applications that we help support. So let's dive in. A little bit about me. I'm a database geek. My day job is I run Altinity, but I actually have worked on databases since 1983. I like to say over 30 years. Doesn't sound as old. Plus, I've done a few digressions into things like QA, virtualization, security, stuff like that. I've been working on analytics now for almost a decade. Altinity, as you probably know from other introductions, we're an enterprise provider for ClickHouse. We run Altinity.cloud, which was the first managed platform for ClickHouse on Amazon and GCP, but not the only one, as you're going to see in this talk. Let's dive in. So this is the second year that we've done OSA Con, and I did a talk last year, which was called State of the Open Source Analytic Universe. I didn't put a year on it, but it was 2021. So I want to just show a couple of points that came out of that were things that seemed interesting at the time, and that are continued trends within open source and within analytics. So the first one is real-time analytics. I just came out of a great talk by Mary Grigleski and Mark Needham talking about P&O and integration with event streams. This is a topic that just continues to grow as more and more people want to have immediate insight into what's going on in the outside world so that they can act on it. And so these are really, really important use cases that are appearing particularly in SaaS applications, which often generate huge amounts of data. You can imagine scanning web logs and doing web analytics, doing bidding, doing telemetry on networks, processing market trading data. These are all applications that generate enormous amounts of data. So it's arriving at millions of events per second. You get trillions of stored events, and I'll show you an example of that in just a second. And you have consumers who often want answers back in less than a second. These are very challenging requirements to meet. They're actually quite new, something that's really emerged over the last decade, that there is now open source software that can handle this well. What does it look like in reality? So here's a couple of screenshots off our cloud platform that show what these systems, just give you some insight into what these systems are like in the field. First of all, very, very high rates of ingest and query, constant operation. So this is an example where the application is feeding 3 million rows per second. If you run the math out, you're going to end up collecting something like 250 trillion rows a day, or excuse me, 250 billion rows a day. And every 4 days, you got 1 trillion rows. This is an enormous amount of data. You run that out for a full year, you're going to have 100 trillion rows. That's a very, very large data set. And then, of course, you have constant query on it, often with unpredictable access patterns. So that's one part, this continuous operation. The other thing is the growth in data is constant. Probably the single most common issue that we deal with in our cloud platform is making sure that people extend storage in a timely fashion because their data sets are growing. So of course, we have this all automated, but we do check in with people because it causes their costs to raise. But what you see is what we started out on the platform, relatively small amounts of data in the hundreds of gigabytes. ClickHouse can actually do quite a bit with that. But now we're seeing instances that have 30 terabytes of attached storage. That's no longer uncommon, and we expect to see that continue to grow. Another interesting thing that from last year was just, I talked a little bit about Kubernetes and its role in managing data. and it is continuing to flourish. So cloud native databases are increasingly widespread. Um, they run very, very well on Kubernetes, and a lot of this is thanks to operators, which are a feature of Kubernetes that allow you to build new resource types, for example, for the ClickHouse database. And that's exactly what Altinity did starting 4 years ago. We developed something called the ClickHouse Kubernetes operator. And you can see here, we're tracking the number of watchers or stars, and it's increased uh, uh, consistently over the last 4 years. So each year, larger number of watchers. This is actually the most, as far as we know, one of the most popular, if not the most popular database operator in GitHub. So that was 2021. This is just a summary of things that we saw. What I'd like to do right now is talk about some things that are interesting trends in 2022 and that you should be watching for. So let's start with the first one, connecting transactions to analytics. So this has always been really important in data processing. Whenever you do anything that uses a credit card, somewhere somebody wants to look at that transaction and make sure that it's okay. So you swipe the credit card. It could be at a point of sale, but it could also be in an e-commerce application. And that transaction is going to land in a fraud detection app somewhere, and it's going to check it and say, hey, it's either fraudulent or not. So what this means in a practical way is that as people begin to do more and more e-commerce and have more of this processed in real time, we're going to have integration between OLAP systems and OLTP systems. The reason is that when you're doing the transaction processing for a credit card, the best place to do it is a row store or with row-oriented data. Has complete transaction models, extremely high concurrency rates, a bunch of advantages. But if you're going to ask the kind of question that you need to ask in a fraud detection app, which often requires you to look at a user's history, may require you to compute aggregates that are complex or expensive, an analytic database with data organized in columns is the best place to be. So this type of architecture is not new, and people have been using ELT to extract, load, transform to move the data out of the row stores into analytics so that they can perform this processing. What is new is some of the things that are happening over the last year or two to try and make this faster. The first thing is to address this. You can keep this architecture, but a key thing is to make sure that that middle arrow is as simple as possible. You don't want this stuff to break. You want it to be really fast, and you want it to be simple. So one of the things that we're actually working on, which is, and we're not the only ones, is to enable simple near real-time transfer of data that hits transaction processing, for example, in MySQL, make it flow immediately to an analytic database, literally within seconds, so that this fraud detection can get kicked off. So, so that's one area that where there's already activity out in open source. We're doing it with Kafka Sync connector for ClickHouse. So we're doing a talk on this later today, so you can find out more about it. But there's actually another really interesting trend that is occurring, which is rather than have to have two separate databases, why not just combine the row store and the column store in a single database? This is what we call HTAP. It's hybrid transactional analytic processing. And this is, like a lot of things in the database world, not new, but what's interesting about it is that more people are doing it. And so if you look around uh, the universe of databases, analytic databases, and OLTP databases, you're starting to see more and more implementations that basically have these two kinds of storage in the same database. Snowflake recently announced that they would be supporting this. PingCap, who's one of our sponsors, and we'll be doing a talk today. We also have a panel discussion, implements exactly this model. And then even traditional databases like Oracle, or database companies like Oracle, are putting out solutions, MySQL HeatWave. So the idea here is just don't have, collapse that integration and just put it all in the same database. So this is something that if you haven't looked at it, it's a really interesting area of technology. In our panel discussion coming up in about 40 minutes, we'll actually be exploring some of the trade-offs between using this versus integrating an OLTP database with OLAP. So that's interesting trend number one. Here's another one, object storage. Again, like everything else, this is not a new idea. The first data warehouse that sort of had a mainstream implementation of storage on or using object storage in the cloud was, of course, Snowflake. They released in 2014, and the basic idea is that they split the compute, which is this upper level, from the storage, which was S3. So they were running on Amazon. And the way that it's implemented is you then have clusters of servers that will then use caches to pull data out of object storage, operate on it, answer questions quickly, and give people their results. So this was a great idea. It's one of the really big, sort of major steps forward in the history of analytic databases, and it's become incredibly popular. So as we look out over the all the databases, particularly the open source ones, every single one of them supports operating on object storage to a greater or lesser extent. By the way, don't feel bad if I left you out. BigQuery's not in this picture. There's so many people doing it, but in the open source, we have, of course, Druid, we have Pinot, we have ClickHouse. Firebolt is an interesting hybrid. It's not an open source database. It's a cloud hyper sort of real-time data warehouse, runs in the cloud. It actually embeds ClickHouse, so it's got a little bit of open source salted in there. One of the most interesting implementations that has come out over the last year, and I think one that's worth looking at closely, is Databricks Photon, where they have basically introduced a new kind of data warehouse, which works on this storage model, but it also has some interesting, it also leverages some kind of interesting trends that are occurring with storage for databases. And this trend is open what we call open table formats. So basically, if you look at databases over time, they have traditionally always had a proprietary storage format. But one of the things that has been evolving over the last few years and is now beginning to sort of be united with data warehouse is the notion of this thing called an open or open table format, where you basically have a storage layer that inherits information about the schema, for example, metadata, security, who can access things, and who can and transaction models, so that you can update the underlying data safely. And so basically, this information is migrating out of the servers and into this intermediate storage layer. We have an example of this in a talk later today. There's a talk about Iceberg, which is one of the implementations. And so as a result, Photon leverages this. What they use is a storage format called Delta Lake, so which was also open source this year. It is similar to Iceberg. And so what we're now seeing is a series of these open data formats, which now can form a storage layer that underlies the data warehouse. But the goal here, and this is a big goal of what, for example, what Databricks is trying to do, it also enables other applications to share this information and work on it, but only have a single copy of the data. This is a very powerful idea because the data sets that we're dealing with, as I just mentioned, sort of a few minutes ago, they can be enormous. They can be many, many trillions of rows. They can extend to many, many petabytes or tens of petabytes. So having the ability to have a single copy of the data and then share it across AI, ingest, data warehouses, and other types of applications is very, very powerful. So I think one of the things I'd like to throw out that hasn't happened yet, but I think it's kind of an intriguing idea, is that there are several of these open data formats out there. ClickHouse, which as you'll see in a minute is an enormously popular data warehouse, actually has a very flexible and fast storage format called merge tree. So one of the interesting things that I am looking for, and we may see it, is to see that format emerge as another one of the open data formats. I'm calling it object tree. That's just my magic name for it. But this is something that, who knows, could emerge from out of the open source community in the next year or two. It's an interesting idea and would allow people to store data in ClickHouse and also have it be reusable by other applications. So that's something to look out for. Um, there's a final trend that I think is really interesting and worth discussing, and that's sort of the fading of Postgres as a source of new analytic projects. This is not to say that Postgres is not an enormously influential and widely used databases, but what if you look at the history of Postgres and particularly analytic systems, everybody who built analytics, or a very large number of them, over the last 20 years, traditionally what they would do is they would go get the latest version of the Postgres code and they would fork it. And so you had things like Astrodata or Greenplum. Greenplum was one of the first that did this. I think they forked around Postgres 8. Netezza ParExcel, which is the engine that later was acquired by Amazon and underlies Redshift. These were all built off Postgres. What's However, if you look at this, these are the ones in black are the databases that are still active. Uh, all of the others are older databases, no longer really growing, no longer really influential. So Postgres is still out there. It's widely used. There are many cloud services that run it, many people who run it in applications at various times or various kinds. What is now happening in the analytics space is its place is being taken by ClickHouse. And here's an example showing both forks as well as cloud services that are built on ClickHouse. So ClickHouse is the core. The folks in yellow are forks, and there are most certainly more than these. These are the ones that are easy to find. Anything outlined in red is a fork that became known within the last year. In this list, that includes Firebolt, which embeds the ClickHouse query engine. There was a really wonderful talk about it about a year ago. The other thing that's happening is there's an enormous number of cloud services that are built on ClickHouse. So the and they I'll show you where they're located, but it's a huge number and it's literally growing every day. The clouds in the blue boxes that are outlined in red, these are clouds that emerged over just the last year, and I think you can take it for granted that there are others in the wings which will come out sooner or later. So this is a huge, this is now, ClickHouse has now become hugely influential as a source of innovation, a source of services, a way to create new and imaginative analytic databases. And we're going to continue to see this grow. So here's just a kind of an interesting picture, which is to take that same representation from the previous page and just map both the forks, which are the yellow circles here, and the cloud services, which are the blue circles, and just map them over the world and just see where they all land. Again, this is a subset of the actual services and forks, but you can see this enormous distribution of ClickHouse. It's basically being used in every country where there's major data processing. What's also kind of interesting is that it's used in countries across different regions of the globe, which basically, if you look at the countries and their relationships with each other, these are people who couldn't even agree on how to make a cup of coffee, but they're all using ClickHouse. So ClickHouse has become pervasive across the planet, and I think is going a long way to achieving the goals of the original designer of Alexei Milovidov, who wanted to make it the default database worldwide, a default analytic database worldwide. So here's some predictions for 2023. So real-time integration from OLTP to OLAP, that's just a corollary of having real-time data. You want to get these transactions into the database as quickly as possible. So we're going to continue to see improvements on that. This is opening up an interesting door for HTAP, which is a new solution for many people. I think we're going to continue to see enormous innovation related to object storage. We're not done by a long shot there. Making object storage perform is a very difficult problem. We'll see innovation to combine real-time data and real-time applications with object storage. The final thing is there'll be more things based on ClickHouse cloud services and forks. I think a simpler way to say this is if there's anything you can think of doing with ClickHouse, there's a pretty good chance somebody's doing it somewhere on a laptop right now. So you're going to see interesting things come out based on ClickHouse over the next year. We'll come back and look at them. So those are the predictions. I'm not quite done. Uh, I think there's one final topic which is really interesting and I think will affect open source, the economics of open source in a profound way, and that's ownership of data. This is a quote from Linus Torvalds, which you can read it yourself, but basically, open source allows you to control your destiny. It's not a new idea. I think people have understood this for a long time. There's entire businesses like Cloudflare that it basically assume that they own the stack. But the key thing here is that open source software enables you to own data. And the reason is that it's no good having a bunch of files out there in S3. You need to have software to access. Therefore, in order to own your own data, to be able to hold on to it and gain value from it, you must also own the code. So if you look at the factors that drive the economics of open source, there are committers who create it, often just because they want to do something interesting. There are communities who come together and work on these projects and build them from little things up to great things. There are vendors who are funded, build businesses on open source, and make it safe for industrial use. And then finally, there are users. There are the people who uh, who are using the open source to achieve their own business purposes. And so what this ownership of data means, and as you think about all the factors that go into the economics of open source, like VCs, like clouds, like innovate, levels of innovation, users have this interesting perspective that they need open source because they need it to own their data. So as a result, one of the things that I predict is I think there's going to be there's always been user interest in open source, but as people start to think about owning the data, like, do I want to have control over the data in these very large analytics systems? They are increasingly going to be a force to develop and maintain open source software because it's the only way that they can achieve that business goal. So that's it. I've run a little bit over time. But I'd like to thank you and hope you enjoy the conference. There's another talk coming up on open source from Peter Zaitsev. Feel free to jump over there. If you have questions about this, I'd be happy to stay around for a moment. Otherwise, I hope you have a great conference and I hope you've enjoyed this talk. Thank you very much.